Hello friends, I welcome you in lecture number 7 on estimation. From last two lectures we are discussing how to find out confidence interval for given sample. So in earlier lecture we have discussed the construction of confidence interval for large samples. In this lecture we will see the construction of confidence interval for small sample. For that we recall the formula for the confidence interval for small sample. So if we are drawing a sample of size n which is less than 30 from a population with mean mu and its standard deviation is unknown, then with 1 minus alpha into 100% confidence level, the confidence interval formula for small sample is x bar minus t alpha by 2 times sample standard deviation s over square root of n less than or equal to population mean mu less than or equal to x bar plus t alpha by 2 times sample standard deviation over square root of n. So this we have discussed in earlier lecture. In lecture number 5 we have discussed that how we can derive this formula for confidence interval with 1 minus alpha into 100%, and here we are assuming that the sample is drawn from a population whose distribution is normal and sample size is small, and we are going to use t distribution table to find out this critical value of t corresponding to given confidence level. So we discussed this question which was asked in GTU winter 2020 exam for the construction of confidence interval for small sample. So first we understand what is this question. It is given that 10 bearings made by a certain process have a mean diameter of 0.506 centimeter and a standard deviation of 0.004 centimeter. So here we are given a sample of size n equal to 10 with sample mean x bar equal to 0.506 and sample standard deviation s equal to 0.004 centimeter. Assuming that the data may be looked upon as a random variable from a normal population, construct a 95% confidence interval for the actual average diameter of bearings made by this process. Actual average diameter means we have to construct the confidence interval for population mean, that is mu. So first we write down all these things. We are given this sample of size n equal to 10, so we write that given that sample size is n equal to 10, we are given sample mean x bar equal to 0.506 centimeter and we are given sample standard deviation s equal to 0.004 centimeter and confidence level is 95%. So we can say that 1 minus alpha is 0.95 and therefore alpha will be equal to 0.05 and hence alpha by 2 is half of 0.05, that is 0.025. So alpha is the area in both the tails. Alpha by 2 is the area in one tail. Now because we have a small sample and we are considering a sample standard deviation, we have to first find out the value of t for which probability that t is greater than t alpha by 2 will be equal to alpha by 2. Here we can see that alpha by 2 is 0.025. So we have to find out this probability 0.025, and we can recall that the shape of T distribution is also bell shaped. So we can understand in this way, this area covered by left as well as right tail is 0.025. Here also we will have 0.025. So this point is T suffix 0.025. Here we will have minus T suffix 0.025, and area in between is 0.95. So we have to find out. Here I should write T suffix 0.025. I don't know what is this value T suffix 0.025. So I can find out T suffix 0.025 from the table of T distribution, and for that we require number of degrees of freedom, and we know that degrees of freedom will be equal to sample size minus 1. Here sample size is 10, so degrees of freedom is 9. So now we find out from the table this value of T suffix 0.025, and we consider this as level of significance in the distribution table. Okay, if we see the distribution table for T distribution, then here we can see that this T alpha is the point such that the area to the right side of T alpha is alpha. Now here we have this type of situation. Our point is 0. T suffix 0.025, and area to the right side is 0.025, and degrees of freedom is n-1 equal to 9. So if we compare with this, here we have T alpha, here we have T suffix 0.025. So we will consider alpha equal to 0.025 for using this table. So here alpha equal to 0.025 is here, and we have to search for nu, that is degrees of freedom. If we recall, degrees of freedom is denoted by this symbol nu. So we search for alpha equal to 0.025 and 9 degrees of freedom. So here we have 9 degrees of freedom, here we have 0.025. So we find out the intersection of these two lines, horizontal and vertical line, and at the point of intersection we obtain the value of T, which is 2.262. So this value T suffix 0.025 is 2.262. Now this type of table is known as one tail or single tail T table. Here we are given the values of T suffix alpha such that area to the right side of T alpha is alpha. Now some authors are using two types of tables for the T distribution, one tail as well as two tail tables. So I am going to explain that also. Using any of these two tables we will obtain the same value. Using this one tail table we obtain that T suffix 0.025 is 2.262. So let me write that value first here. T suffix 0.025 which we obtain using this one tail table is 2.262. So here I write 2.262. So this I obtain using one tail and using alpha equal to 0.025 and 9 degrees of freedom. Now we observe this table. Here we are given degrees of freedom. Here it is written that this is the significance level for two-tailed test and this is significance level for one-tailed test. Now in our case we have this type of situation. Suppose I again consider the graph, then I have this type of situation. Area in both the tails, total area which we consider as alpha is 0.05, area covered in both the tails, and area covered by single tail or one tail is 0.025. So this point we denote by T alpha by 2, this point we denote by minus T alpha by 2, there will be 0 somewhere here. So area in both the tails, total area is 0.05 in both the tails, and area covered by single tail is 0.025. So if we want to use one-tailed test, we will use this value 0.025. That is, we consider T alpha by 2 which is equal to T suffix 0.025. So we will use this as significance level 0.025. If we convert in percentage, then it is 2.5%. So level of significance for one-tailed test, if we concentrate on the one-tailed area, then significance level is 2.5%. So if we want to use one-tailed test, we will consider this row and we will search for 2.5%. So this is 2.5%. Now degrees of freedom is 9. So we can see at the intersection we will obtain 2.262, which I just obtained using this table. This is the table for one-tail test. So if we consider area covered in single tail, and the corresponding value of T will be T suffix 0.025. So we consider one-tailed test. Now suppose we want to use two-tailed test, then we consider the area covered in both the tails. That means we have to consider this as alpha. We know that area covered in both the tails is sum of these two areas, which is 0.025. So for two-tailed area we have alpha equal to 0.05. So significance level in percentage becomes 5%. So in that case we will concentrate here two-tailed test, and under two-tailed test we will find out 5% significance level. So here we have 5% significance level. So we are using this two-tailed test and 9 degrees of freedom, and we can see we have the same value 2.262. So as per the conveniency of given table in the examination, or as per your choice, either you can use one-tail test or two-tail test. Okay, if you are given the table for one-tail test, then also no problem, you can use this T table to find out critical value of T. So in this way we have obtained the critical value of T, and we are going to use this critical value in constructing the confidence interval. So here T suffix 0.025 is 2.262, or we can write this is T alpha by 2, where alpha by 2 is 0.025. Now we have ready-made formula for the confidence interval. Here we can say that sample size is small, so n is less than 30, and population standard deviation is unknown. We have small sample confidence interval formula, or small sample confidence interval is x bar minus T suffix alpha by 2 times sample standard deviation over square root of n less than or equal to population mean mu less than or equal to x bar plus t alpha by 2 times sample standard deviation over square root of n. Now we have all these values, we substitute them. X bar is 0.506 minus t alpha by 2, that is 2.262, so that we write here 2.262 into sample size is 10 and sample standard deviation is 0.004. 0.004 less than or equal to mean mu less than or equal to 0.506 plus I have to write same quantity here, 2.262 into 0.004 divided by square root of 10. So using scientific calculator I obtained that confidence interval required is 0.5031 less than or equal to mu less than or equal to 0.5081. So we are sure with 95% confidence that the population mean mu for given process lies between these two values, 0.5031 to 0.5081. So this is the required confidence interval. Okay, we are asked to construct the confidence interval and we are able to construct the required confidence interval for small sample. Okay, so in this way we can construct the small sample confidence interval. You just have to remember this formula, x bar plus or minus t alpha by 2 s over square root of n. For large samples we are using sigma here, population standard deviation, if it is known to us. If it is unknown, then we are using sample standard deviation for large samples also. But for large samples we are using standard normal distribution instead of t distribution. For small samples coming from a normal distribution we are using t distribution. So it is easy to construct the confidence interval formula for small samples, but you must be familiar with all these things, how to find out critical values of t using one tail or two tail test, and you must be familiar with this formula. So this is all about this session. I hope you like it. Thank you very much.